Welcome to True Projects. In this video, we are going to explain about the project that is enhancing chronic disease prediction in IoMT-enabled healthcare 5.0 using deep machine learning, Alzheimer's disease as a case study. So before getting into the execution, first let us understand what is the project about. So chronic diseases, they are long-lasting illness that don't go away quickly and they can seriously affect a person's health. Examples include diabetes, heart problems, cancer, and brain related diseases like Alzheimer's. Because these diseases last for long period of time, people often need ongoing medical care and their everyday life can be affected. They might struggle with daily activities or they need constant monitoring. So, catching these diseases early and starting treatment on time is very important. Early diagnosis can prevent the illness from getting worse, reduce complications, and also improve the person's overall health and quality of life. On top of that, certain lifestyle habits like eating unhealthy food, not being physically active, smoking, or drinking too much alcohol can increase the chances of developing these diseases. That's why paying attention to healthy habits and regular health checkups is crucial for prevention and better long term health. Here, even though chronic diseases are common and they have big impact on people's lives, finding them early is still very difficult. Traditional methods they usually depend on doctors and manually reviewing patient information, which can take a lot of time and may sometimes lead to mistakes. These methods also struggle when dealing with the complex medical data such as detailed scans or large clinical records. Because of these challenges, there is clear need for smarter and more accurate ways to look at this health information. So by using advanced techniques to analyze diverse types of medical data, we can identify risk factors earlier, diagnose diseases sooner, and provide better care. This not only helps to save lives but also reduce the financial burden on patients and the healthcare system. So here to overcome with all such issues, the proposed system, that is, this project is designed to make predictions on chronic diseases, especially Alzheimer's disease, faster and more accurate. For that, it uses machine learning methods along with the MRI scans of the brain. Here, the main idea is to catch the disease early so that patients can get treatment sooner and have better health outcomes. For implementing this, the system uses a technique called transfer learning, that is the ResNet 101 model to help classifying images, that is MRI scans, into different stages of Alzheimer's. That is mild dementia, moderate dementia, very mild dementia, and no dementia. Because of this model, that is this transfer learning model, it uses pre-trained models so that it can understand and also extract patterns from MRI images even if there isn't a lot of labeled data available. In the end, this approach creates an automated, reliable, and accurate tool for early disease detection which supports the vision of the healthcare by providing predictive, personalized, and efficient medical care. Moving on, to further improve the performance of this project, here we are employing NASNet and Ensemble model for classification to get a better understanding of the dataset and improve how accurately we could classify the images. This means the system became better at recognizing different types of cases in the data. And additionally, we have also introduced a detection module using YOLO family to detect problems or abnormalities in the MRI images. So these models, they don't just tell us what type of abnormality is present. Instead, they also show exactly where it is in the image by drawing a bounding box around it. So this extension helps the system both locate and also identify issues in the MRI images more effectively. And to make it easier to understand why the model make certain predictions, we have used technique called GradCam, which is part of explainable AI. So this GradCam, it creates heat maps on the images that show which areas were the most important for the model when making its decision. In other words, it visually highlights the regions of the MRI images that the model focused on the most. This helped doctors and researchers see what influenced the prediction, making the system more transparent and also trustworthy. Here we have also created a web application using Flask to make the system easy for users to interact with. Through this interface, users can upload their MRI images and the trained model will be analyzing the images and provide predictions. This setup makes the process smoother and interactive, so users don't need to run any complicated software or code themselves. They can simply use a web app to get results quickly and easily. So this is the extension part. Now moving on to the implementation. To implement this project, we have followed the steps which are mentioned in the flow of work. So these are the steps followed. Let's understand each of them step by step. So first, for classifying the Alzheimer disease, here first step is data preparation. So first we did data preparation where MRI images are collected and each image is labeled with its corresponding tumor type. And then the data set is split into training, validation, and testing sets to train the model and evaluate its performance. Then comes visualization. So here the distribution of tumor types in the data set is visualized using a bar chart to understand class balance. And in the next step, sample images with labels are displayed to ensure that the data is correct and properly labeled. Then comes pre-processing. So here in the step, images are resized to a standard size and normalized to scale pixel values for better model performance. And data augmentation techniques like flipping and rotation are applied to increase the data set size and also variety. And here we have also used HOG. So that is histogram oriented features. Histogram of oriented gradient features are extracted to capture important patterns in images. After that, we split the data into training, testing, and validation sets. Then comes model training. So here in the step, deep learning models like ResNet, Exception, and the ensemble models are trained on the prepared data set to classify tumor types. Then comes evaluation, that is model evaluation. So here the trained models are evaluated using metrics like accuracy, precision, recall, FN score, confusion matrix, and ROC curve to measure the performance. Then comes the next step, that is inference pipeline. So here, when a new MRI image is provided, the model predicts the tumor type and provides a confidence score indicating the certainty of its prediction. So this is how we have done classification. Now moving on to the detection part. Here also, first step comes data preparation. So here all the MRI images are collected for tumor detection, and then bounding boxes for tumor regions are created in the YOLO format .txt files on the file that is for every image. After that, the dataset is divided into trained, validation, and testing sets. Then comes visualization part. So here sample images with the bounding boxes are displayed to verify the annotations and it is correct or not. Then comes data pre-processing. So here images are resized, normalized, and augmented for better model learning. A data.yml file is prepared with image paths and class names for YOLO training. Then comes model training. So here YOLO models are trained to detect and classify tumor regions in the images. And each model, so here, each model predicts both the location, that is bounding box, and also the tumor type. Here, performance is measured through mean average precision, that is MAP, precision, and recall. Then comes inference pipeline. So here, when a new X-ray image is provided, the YOLO model outputs an annotated image with the bounding box and confidence codes for detected tumors. So this is how we have done detection. Now moving on to the front end part here. In the front end, user give input as MRI images. So first, here we have developed front end with a Flask web application. And in that application, users will be able to provide the MRI images that will be pre-processed at the backend. If you have given image for classification, model will be classifying the tumor, that is the Alzheimer. If you have given for detection, it will be detecting where the tumor is and it will be telling whether the person has Alzheimer or not. If he has, which stage of Alzheimer stage he is in, it will be displaying. And now moving on to the output display, it will show the output, that is whether the person has Alzheimer or not with the confidence score. And moving on to the algorithms used for classification, we have used two types of models, that is transfer learning models and also machine learning models. In transfer learning, we have used ResNet 101, DCNN, that is Deep Convolutional Neural Network, exception, that is the CNN architecture. And also we have used NASNet mobile. And also we have used ensemble model here. See, traditional machine learning models, K nearest neighbor we have used, random forest, logistic regression, and XGBoost. And the extension model, which is a combination of NASNet plus exception, which is an ensemble model. And coming to the detection models, here we have used YOLO V5, YOLO V8, YOLO V9, and YOLO V11. YOLO refers to you only look once. To implement this project, we need two kinds of requirements, which are hardware and software. In hardware, we need operating system of Windows, processor of 5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Software are application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. So this is the overview of the project. Now let's execute it. To execute, let's open the code folder of the project. These are the source code files in the code folder of the project. Let us understand each of them. So in this folder, we have the dataset that is used. Open it. We have split the data into three folders: train, validation, and test. Let's open images which are in the train folder. So here we have four different kinds of images. That is four different types of MRI scans. In the first folder, we have mild dementia, persons with very mild dementia. Get back. Persons with moderate dementia. So here we have images of where there is no dementia. These are the MRI scans of brain. Accordingly, we have images of brain MRI scans where there is very mild dementia. So images which are in these four folders will be used for training the classification models. Let's get back. And here in these two folders also we have images. So they will be used for evaluating the models which we have trained for classification. Get back. And here in the model folder, we have the algorithm information that will be loaded into the project code during runtime of the application. And this is the static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap files, which are important for the visual appeal. And here in the templates folder, this folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different web pages of the website. And here in this folder, we have the test cases that we will be using in the front end. So we have test cases for the classification as well as detection. Get back. And in this YOLO folder, we have the dataset that is used for detection. Here we have dataset in train and validation. Let's open the train folder. Here we have images. So these are the images of all classes. We have mixed all four types of classes here. We will be training detection on these images. And annotation files we have in this label folder. Let's open it. So here, this folder contains all the text files. So these are the object locations or labels for the objects in the corresponding images. Here, each label file, it corresponds to an image in the image folder. For example, the first image, that is the first text file, it corresponds to the first image in the first folder, which means it provides, that is a txt file, that is file which we have in the label folder. It provides object locations of this image, that is the tumor locations of this image. Accordingly, for the second image, the tumor locations will be in the second label file. We have in this label file. Accordingly, for all the images that we have in the images folder, we will be having all the label files. So all these files, they follow the YOLO format where each line represents a detected object. For example, let's open a file for sample. So here we have different classes. So here we have different lines where each line, it represents a detected object, which is followed by its bounding box coordinates. Close this, get back. Accordingly, we will be having the validation. So this validation folder is used for evaluating the YOLO models. Get back. And this is the app.py file. So this .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML templates. And here we have notebook files. So these are the notebook files, which are also called as Jupyter Notebook files. And they contain a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in cells, that is individual cells, which makes it a popular choice for the data science. So in this classification Jupyter Notebook file, we will be loading this data set and we will be training all the models for classifying the Alzheimer's disease. And for the detection purpose, we have this notebook file. This is the signup.db file. This file is the database file which is used to store the user information. So this is all about the code folder. Now let's execute. To execute, copy the path of the code folder from the address bar of the file explorer. I have copied it. Now open Anaconda prompt. So it is open. Give the command cd, give the space, paste the copied path and click on enter. Here, if you observe, current directory is changed to the code folder's path. Now compile app.py file. So give the command python space app.py and click on enter. This command will execute Python script and perform a runtime check for any syntax errors or logical issues. And after running the app.py file, Flask framework will host the application locally at the default address, which will be the local host and the port unless configured differently. So just wait for a while. So here, localhost has been generated. So this is the localhost and this 5000 is the port. Now copy this local address provided by the Flask framework and paste it into any web application, that is any web browser. So copy it. I prefer Google Chrome, so I will paste it in that. Paste the link here, click on enter. This is the web page of the project which is displayed in the browser and this is developed using Flask framework. So this is the web page. Now we need to get signed up first. So click on sign up and enter all the registration details if you are registering newly. I have already registered, that is I have already created the account. So I will directly sign in, click on sign in, give your username and the password. And now click on sign in. We have signed in successfully and redirected to prediction page of the project. So here under prediction, we have classification as well as detection. So first let's do classification. Click on that. Here you can see a select file option. We need to click on that for uploading the images and then we need to analyze the brain scan. So click on select file. Now open test cases. As we're doing classification, open classification folder. So now let's upload images from this folder. Let's select this image, click on open and now click on. So this is the image that we will be uploading and now click on analyze brain scan. So this given image, it will be pre-processed at the backend. It will be fed with the trained model and then trained model will be giving us a prediction. So here the backend process will be happening here. So you can observe backend process being happening here. So just wait for a while until we get the prediction. So here we got the prediction. This is the original image that we have uploaded. And here we got the prediction that it is mild dementia. That is primary classification that we have done. Here we can see a GradCam image, which is an extension of this project. So GradCam image is an explainable feature image. So from this GradCam image, it highlights the regions of the MRI that the model considers most important for its prediction. Here we can see red and yellow. So these areas show the high influence, indicating where the model focused to classify the tumor. It helps to validate the model and support medical interpretation. With this, we can understand which regions the model has been focused for predicting whether the person has dementia or not. If it is at which stage? So it is at very mild stage. And this is the confidence level that how accurate the detection is. Now let's try scanning another image. Click on select file. Get back. Let's try with this folder. Let's select this one. Click on open. And now click on. So this is the image that we'll be uploading. Click on Analyze Brain Scan. Here we got the prediction. This is the original image and this is the GradCam image. These are the areas where model is focusing on and it is predicting that it is moderate dementia. Let's try some more. Click on Select File. Get back. Let's upload this one and click on Analyze and Scan. So here we got the prediction that it is no dementia. Now let's try with another one. Click on Select Image, that is Select File. Now let's upload image from the last folder. So let's select this one and click on Analyze Brain Scan. So here we got the prediction. This is the original image we have uploaded and this is the GradCam generated image. Here we got the prediction that it is very mild dementia. And here you can save report for every prediction if you want. So this is all about the classification. So in classification, what we have done is we have uploaded the image and application was only just telling whether it was dementia or not. If it is dementia, it is of which stage. Now, if you do detection, you will see the difference. So let's do detection. Click on detection. Click on choose scan. Get back. Open detection folder. Open images. So let's try with this image. Click on open. So this one we will be detecting. And now click on detect lesions. So here we got the detection. Here you can observe a blue color bounding box is drawn around it and predicting it as mild Alzheimer's. That is with a 0.98 probability score. That is the confidence level, how accurate the detection is in detecting this particular class, that is mild Alzheimer. Coming to classification, it was just telling whether the person has Alzheimer's or not. Coming to detection, it is highlighting the area where that issue is happening. Let's try with some more. Click on choose scan. So now let's upload this one. And now click on detect lesions. So here you can observe moderate Alzheimer's has been detected with a 0.99 probability score. And here we can also export the report. Now let's try with the another image. Click on choose scan. So now let us upload this one and click on detect lesions. So here we can observe that there is no Alzheimer's for the person. Let's try with last image. Click on choose scan. Let's try with this image. Click on detect lesions. So here you can observe very mild Alzheimer's have been detected. So this is how you need to do classification and also detection. Now let's check with the analytics, that is the graphs. First, let's see for the classification. So here, this is the sample outcome graph that shows the class distribution. Here on x-axis, you can see all the classes that we are predicted. And on y-axis, we have number of images that we have for each image. Get back. Close this. And here you can see number of images after splitting. So here, images which are used for training is this part and images which are used for testing is this part, that is the yellow one, and for validation it is red color. Close it. And here this is the ROC curve. This is the ROC curve of the extension model ensemble. This is the confusion matrix. So this is the confusion matrix. And here we have accuracy score. So it is a metric that is used for evaluating classification models. So here on x-axis we have all the models that we have trained and on y-axis we have accuracy score. Close it. And here we have precision score. So this is the precision score. Accordingly, we have for the all the metrics. And this is the stacked bar of accuracy plus FN score. Here, this purple represents accuracy and yellow represents FN score. Accordingly, we have for stacked bar of precision and recall. Now let's see with the detection. Click on detection. So here we have YOLO metrics. So let's click on view. Here on x-axis, we have all the YOLO models that we have trained and on y-axis, we have precision. So this precision is the evaluation metric that is used for evaluating the model. And here we have for the recall score and here we have for the mean average precision score. Now click on sign out. In this way, just by uploading image to the application, it will be first detecting whether the person has Alzheimer's or not. If yes, it will give which stage it is. If no, it will just tell no Alzheimer's. And also the same case of detection, it will highlight the area where disease is present. So this is all about the project.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Project's YouTube channel and subscribe.